maybe we should flip this around a bit, and perhaps the eSaúde team can start off with 5 minutes about what they are. Why are we having this call now? They sort of raised this question of wanting to do data warehousing, and maybe you can give just a little bit of insight into what your needs and goals are, and what is your target.
So I'll start, but Idris and Hamilton, you can contribute along. So for eSaúde, what we want is to have a faster way of retrieving information from OpenMRS, and as we know, the more the ops table grow, and we're writing our reports using reporting framework, it takes longer to run, for example, an indicator report, something that could take like 6 hours and above to run a report that maybe someone would expect it to be within minutes. So this has been a problem, especially when the ministry will want to click a report on the fly and just have it run. So recently we thought like we can split down the patient information from the ops table just to fit the reporting needs into multiple other tables. So we have ended up using Pentaho and Kettle to create our pipelining mechanism into a different database that we try to write those queries directly from that database, thereby reducing time. But we thought like maybe what we are doing is not the correct way of doing things, and that's why we thought we could have a call with those people who've already done this, so that we can learn the best way to approach to that. So one thing that maybe I've been talking about all the time is, if we're using the same OpenMRS data model, why everyone have their own way of reporting from the same OpenMRS? Can't we have a generic way of doing this? So the goal of this call is to learn from what others have done, and maybe come up with the best solution that could not only work for eSaúde, but maybe for the entire OpenMRS community. Idris, if you have something you can add.
Yes, Nicholas, I think you basically stated the main problems we had. The other thing is we are noticing that the report queries are becoming quite complex. So the other goal we had was to make those report queries simpler, to make it faster to develop the reports. And while doing this, we thought that maybe we could use an approach that later we could put an analytics platform or something like that on top, so that instead of creating reports like we are doing right now, we could move this thing to the user, where the user can make more specific analysis and cross the data and everything. But I would say that the main triggers for this work was exactly the time that's taken to generate reports, and also the complexity of the queries. This is what initially motivated us to start this work.
Thanks. That's a helpful overview. And do you actually have it sounds like you have reports that exist already, so it's not a blocker per se to set this up, but you can't run it, you can't go on forever in the current way. Or do you have a specific timeline by which you're intending to do things?
So this faster reports are required like yesterday, because the ministry will just want to see reports. So we just halted a little bit because of the release that we had. But after this release is done, which is done already now, we need to focus some time into pulling information out of OpenMRS. And the faster we do it, the easier and the faster way people will adapt our system. So our system is good. We are writing good codes. We are writing good user interfaces. But now getting information out is the problem. So the timeline is as soon as possible. Is that enough?
Sure. Well, okay. Yes, a lot of timelines are as soon as possible. Do you have, for example, you expect to be working on this over like the next 3 months, over, you know, or maybe it'll be ready in a week, or no? I mean, do you have it? It's fine if you don't really have any specifics that you can share.
We have two things. We have two things that we're working on right now. We have this one of Upgrade 2.x and this data warehouse. So our team can subdivide into two. We have the ones who are focused on making sure our platform is to the latest one, and another one that is focused towards reporting and make sure we have this data warehouse into place. But everything we're working as a team, but we'll have to split it through so that next release that we'll be having, say in the next few months, say 3 months, we should be having these faster reports on the UI and people can just access them faster.
Okay, that makes sense.
Yeah.
Okay, so let's see. So now I guess we can have Pramita, Mike, and Nikki each spend, well, now it should be less than 10 minutes because our call is only, well, we missed 40% of our time getting started. So maybe, yeah, so let's see. So Pramita, can you, I guess, screen share, or I assume you want to screen share. And if it turns out that you need a plugin, you did share some slides with me, so I could also screen share them. Burke, you should probably stop sharing. Oh, wait, you did already. Never mind. Looks like Pramita just got disconnected. So maybe we want to switch the order. Like Mike, would you like to go first?
Sure, I could do that if that makes sense. You guys hear me?
Yeah.
Yes.
Yes, I can hear you.
So I don't have anything explicit, like I don't have any slides or a demo to show, but I mean I could walk through some of what it looks like if that's helpful. But I mean just to quickly sum up, I mean what we're really doing is just doing a nightly process, or on a schedule, not in real time, but on some periodic schedule, loading from scratch a separate database. Yeah, typically in the same OpenMRS. It's in the same MySQL database, but separate from the OpenMRS database. Basically a data mart of data that's extracted and flattened from the OpenMRS data model, and then it has further processes run on top of that to create smaller, more focused tables that contain data that's more straightforward to access, that's answering specific questions or covering certain areas. So like a lab results table, or an HIV like ART register table or something like that. So the idea is that just like what was being described previously for what eSaúde is looking for, the goal being to speed up reports, to provide data in a straightforward way to those who might not be particularly familiar with the OpenMRS data model or all the available concepts and other configuration options, and just to put the data into a structure that could be more easily consumed and understood. And then to And then to provide further sort of ETL opportunities where we can drill down and narrow down the data into specific areas that can be more efficiently queried for not just for overall reports, but connecting external tools into that. I'm not sure that was particularly helpful, but I think the bottom line is we use Pentaho and Kettle as was described before to ETL our data into a data mart that's more easily queryable. It's a batch process, and this is sort of a step for us in the right direction, but we don't view it as an endpoint. And we are continuing to look for ways to improve upon this in ways that makes data more accessible for operational use in real time, like on patient summaries and querying within the system, as well as it's more scalable down the road in terms of the process that's in place right now. Because we refresh the database nightly, we basically run the entire thing from scratch on into an empty database, and that can take several hours when it comes to both getting a backup of the production system, sourcing that somewhere, and then running the ETL process off of that, which is generally the process that we take.
So how thoroughly have you been able to flatten things? Like, have you been able to flatten forms or like encounters to have their obs, columns for the observations or anything like that?
I mean, the approach we took was that, rightly or wrongly, it's a multi-staged process. So the first, job in the pipeline is meant to be really almost as generic as possible, where any OpenMRS implementation could take this and run it, and it would just flatten data, basically out of the configurability.
So
it would flatten
the first
data into
stage does something like it puts in encounter type name instead of
exactly. I mean, there's still like an
encounter.
obs table, there's still a person table, but there's not like a person there's not a person name table, a person address table. There's no type tables. Those are just flattened into names. Where possible, we say like, well, you shouldn't have to make a 5-table join just to get like a patient, their name and their address. But let's make some opinionated decisions that we just need the most recent address for a patient, or assume one address per patient, one name per patient. Combine person and patient, get rid of all the voided data, and just sort of try to reduce the complexity around some of that stuff initially. So no one has to ever worry about voided again. No one ever has to worry about how to join on names or addresses, accidentally get back two patient rows when they really want one patient row because a patient happens to have 2 names in the database. Just basic mistakes that are made when querying the data model because of some of the way joins are happening, or assumptions that are incorrectly made about how many of XYZ things a patient or a person has. Try to eliminate those from the get-go, so that at least people can just say, I want to go to the warehouse patient table, and I know there's going to be 1 row per patient, and it's going to have their address, their name, their gender, and their age, and in an easy to query way.
And so then the later phases, so that's the first phase.
So that's sort of the first phase, just trying to make OpenMRS more accessible to people. And then the next phase would be, okay, now that we have that laid out that way, and it doesn't have to be a second phase, it was just more straightforward for us to do it this way, because we can say, apply this generically to all of our implementations, and then have more implementation specific or use case specific jobs that run subsequently. So we have that first job that runs, then the next job would say, okay, in Malawi, we don't want to have like address 1, address 2, address 3 through address 10. We want to have, a patient table that has columns called, village, traditional authority, and district. In Malawi, we have all of our programs are designed in a certain way where there's a register in which you want to track every patient ever enrolled in the program, and some information about their enrollment history at a location. Then you have want to track like all their visit history within the context of that program. So for XYZ encounter types, one row per visit with with certain data points about those visits. There's like a small subset of lab tests that we really truly care about for a lot of those programs. So for HIV, it's it's viral load, maybe CD4 and HIV test results. So there's a very clear way where we make sure that we have those types of tests in an easily accessible database table for retrieval. So it's those kinds of things that we're doing.
And then reading from those is kind of your own kind of reporting tools or bespoke tools, or are you able to use just like commodity tools like Pentaho?
So there's two ways. I mean, one, we just basically point our data team, our MEQ team at those databases, and we say, look, you should be able to understand what these tables mean now. We can document those tables, and there's not a layer of like this. You need some specific OpenMRS knowledge to understand these. They're they're data in a database. They have straightforward table names and column names, and you can they do what they say they do. And so they point tools like Power BI or Tableau or Excel into those and do their analyses. Where our data volume is not particularly high, like in Malawi, for example, we can run this entire pipeline in like 3 to 5 minutes from scratch. Drop the reporting database, create it from scratch, and run the pipeline against our production database, and then the whole thing's populated in a few minutes. So we do that periodically throughout. Right now we're doing it nightly, but we could be doing it every hour or something. And then we have reports written in the reporting module that just hit that database instead of the OpenMRS database. So operational reports in the EMR are using it as well.
Okay. So are you able to use all the objects from the reporting framework, like coded data types, like coded cohort definitions and so on?
No.
Or you need just to write your own dataset definitions for that?
Well, yeah. I mean, those constructs in the reporting module are built to work off of the core data model. But I mean, the design of the reporting module is such that you just have to create a definition in an evaluator to evaluate that. So if you wanted to change your data source, you have to create a data, some sort of definition that will.
But more or less conceptually, more or less, you could be like doing SQL queries against this different.
We have pretty much moved to SQL with this data model. Our approach, with the reporting module takes an approach where Java is making these decisions and we're encapsulating these queries in Java. And with this ETL approach, it's more like actually we're going to move our logic into the ETL layer so that basically you can get anything with a straightforward SQL query.
All right, and just mindful of time, we probably should move to the
bottom. Yeah, thanks, Mike.
Sure.
That's helpful. We even, as the few we started writing, we were just writing SQL statements directly to the new database, and having the OpenMRS user given all the rights to it, then you can just call it on the reporting framework.
Yeah, I think that kind of at a very fundamental level, you could say write some SQL, generic or not, that flattens the tables from the operational data model of OpenMRS into kind of flatter, easier to consume data tables. And whether you reuse that back in reporting within OpenMRS or you use custom tools, or commodity tools like Tableau or Excel or whatever against those, it just basically is taking the data and transforming it into a flat model that's easier for people to work with and understand from a reporting standpoint.
One thing we haven't done yet, but based on someone's recommendation, I forget who it was, I think it was someone on the Bomley team, we started looking at whether or not like Metabase is something we want to just play around with installing and putting on top of this flattened database as well. That looks promising.
But the data model you've come up with in terms of your flattened one is you've tried to create a generic one, but it's one that it's basically a data model that PIH is using for their sites. So let's.
I mean, yeah, I'm confident that we can come up with a generic one.
Yeah.
If we chose to, that's an intermediary. It's not going to be the most efficient, but it could be generic enough to get people started.
Yeah. So let's, before we lose the folks from Bomni, why don't we move on to Bomni?
So I'm screen sharing here some slides that Pramita shared with me. Pramita, are you there and do you have audio and can you talk? Okay.
Yeah, I'll go through it. So this is just a basic slide. I think everyone is aware. The business objective is for us to create one analytical data model because we are having this OpenMRS hierarchical data model. It is becoming very difficult to attach it to any analytical tool and run reports. So in order to get any reports, we had to write separate views for that and generate reports and or generate whatever data or indicators we want from that. For several implementations, it was implementation specific, and we have to spend a lot of time doing that. So we have analyzed the OpenMRS data model, and then we thought there are 3 types of data. So going to the next slide. So the approach we have taken is first type of data which we have considered is hierarchical data, which is stored in observations. So as everyone is aware, say considering this as a form, this form gets stored in multiple rows in an observation ops table with the parent ID and the parent ID can even have another parent ID. So based on this hierarchy, we have come up with flattening in such a way that every form becomes a table now. So this simple table, like whatever is captured here, will finally become into a one table where one form or one observation in one encounter will be captured in a single row for a person. So for this person, in this encounter, whatever are the concepts on the form, everything will be captured in a single row. So this validation stands valid for forms, and we have even used some tables like some forms like bacteriology, and we have customized to Bermney, but everything gets stored in ops table in a hierarchical manner. So forms data will get flattened into each form into a separate table, and something like which if we are using it, if we are using a form to capture some what are the labs tests if we are ordering, we are using some forms to capture that. So that forms get flattened into a separate table. And one of the issues with this is multi-select and add more. So in case of multi-select and add more, we are flattening them into separate tables so that every selection comes as a separate row so that it will become easier for analysis. So this is one kind of data which we have identified. The other kind of data is in the next slide, which is attributes. So for example, if we wanted person attributes data or any user defined fields basically. So for example, like person attributes. So this data is captured in 2 tables currently. One is where we define the attribute types, and another table which actually holds the attributes, giving the attribute type ID which is there and the actual value. So if someone wants to perform an analysis to ask that, say for person ID 124, I want all the attributes, like I want to know the given names, age, date of birth, and all the registration attributes, like what from the addresses from which the person is coming, or any custom attributes. In this case, it is showed as different rows actually, which is becoming very difficult to do analysis. So the way we have flattened it is we have written FTL such that both tables get combined together, and we can be like every attribute becomes a row, it becomes a column. So in this way, there will be only one row per patient with all the attributes. So this becomes easy for analysis, and we have flattened it in such a way that, like, because these attributes are user defined, we need not give any input to the sequence or anything. Like we don't need to write where conditions or something based upon the inputs. So the system will identify what are the attributes and it will flatten it in this way. The third set we have identified is where the data is there, like the data is directly there without any hierarchy or anything, but it is spread across multiple tables. Like just to get a patient state, like what is the start date and end date of the patient state, we had to combine so many tables to understand the actual state of the patient. So as I have mentioned here, like patient, we have to join the program tables with states and then with the concept tables to get the name of the concepts and all these things. So we have identified a few things which are very common and then join with multiple tables, just like what Mike was saying, like we don't have these IDs anymore. Like we have all the names joined together, which will give a flattened view actually. So this is basically the approach we have taken. Now to keep it generic, we wanted to have this approach to be generic in such a way that it can be run on any implementation. So the technical approach which we have taken is mm, it's a batch job that runs, and every time it runs, it takes the OpenMRS database as input and outputs into a Postgres smart database. So the smart database will have all these flattened tables now. This can be attached to any of the analytical tool and can be used for analysis further. And the way we have written the jobs is configurable jobs. So we are using a Spring Batch application. So the whole application sits in the Spring Cloud, so that if someone else, if someone else wanted to write another batch job to flatten it in a different way or to flatten any other module, they can plug in their batch jar also. Like currently, say we are now preparing this reporting batch job. Tomorrow some other implementation wanted to do something in addition to reporting batch job, they can write one more Spring Batch job and attach it to the Spring Cloud and run together. So Spring Batch works in such a way that every job, like it's all jobs. So we have configured every job. Every job is configurable. Like the first job, like once the job flattened ops, like once the ops job to flatten the ops table is done, it goes to flatten the patient data and then the flatten program data and so on. And we have made it configurable in such a way that, say, there are different job types like custom SQLs. You can create your own job type with SQL by giving a reader SQL. So it will join multiple tables in OpenMRS database and will give it as an output data and will give a single table in the Mart database. Similarly, we can say configure ops job also. In ops job, we can say that I don't want any person identifiable information. So there are a lot of information, like we don't want to expose names or some sensitive data which we are capturing in forms or a registration page or as person details or anything. So we have a configuration to say what all columns or what all data you wanted to ignore. So that also is configurable. And we have observed that all this data, like whatever we are capturing in the database, I mean, most of them are understandable in text format. But for analytical tools to and perform analysis, its text is very difficult. So they mostly depend upon numbers actually. Something like if we wanted to say the status is true or false, instead of giving true or false, they mostly understand 1 or 0 is easier for them, for the analytical tools to understand. So in order to transform that data also, we are using the OpenMRS concept reference source tables, and we can give codes, and the whole Mart database will be numeric actually, so that people can perform tools. And we are also providing a dictionary so that what code matches to what text, people can convert it. This is configurable option. If needed, it can be used, otherwise no. And also, no matter how much we flatten, in order to write some specific indicators or implementation specific indicators, people always need views. These views can be created on tools also, but to make it easier, we are also giving a configuration so that implementers can write their own views and plug it to this application. And every time the application runs, it will just prepare this view so that we can have the whole data actually in a view, and indicators or reports can be generated from these views actually. And one of the thing which we have identified is performing analysis on free text concepts is really not possible much. Most of the people don't use free text concepts for performing analysis. So we are providing a configuration to remove that free text configuration also. So basically what we try to do was make it more configurable so that any implementation can use it as a generic approach. And we are identifying like how can we combine tables together and come up with some specific set of tables which are very useful actually. So this is the basis of how we are doing. We are now concentrating mostly on getting a Mart database out. So once the database is out, how like we should be able to plug into any tool and play around and generate reports is what our idea is. Any questions so far?
And just sorry to add, I think, so this, you're writing this, of course, targeting Bomni, and you mentioned, like, for example, the processor that takes the OBS table and flattens it into like one table per form. That's based on the way that Bomni defines forms. So if someone else wanted
Yes.
to do that with, you know, a non-Bomni version of OpenMRS, they would need to rewrite that process. But
Yes.
I mean, they could presumably copy sort of the approach from what's being done.
Yeah.
Whereas things like flattening attributes probably just would work out of the box with any OpenMRS setup.
Yes.
And you're doing this using Spring Batch, so code is generally
Yes.
written in Java, or is
Yes.
most of it SQL? I mean, I know that you can run some SQL also.
Yeah, so what we are doing is we are using Spring Batch to run each job, and we are using FTLs to generate dynamic SQLs to do the jobs actually.
I see. So as in you can write Java code that will dynamically produce SQL, and that then.
Sorry, I could not hear.
Since you can write Java code, you can therefore produce dynamic SQL, which then SQL itself is what largely gets run.
Yes. So you
Okay.
can also provide a custom SQL as input. So that is like if you wanted to join some 5 tables and create one single table, which is like in I have shown, and plug it in the configuration. Dynamically, if we wanted to do like attributes and all, do is attribute type table name and what is the attribute, where are the attributes stored in which table, and the in the columns in like what are the dependent columns actually. So and then we generate dynamic FTLs based on that, and we flatten it.
Okay. So sorry, just looking at the time, I wonder if eSaúde has any questions for us before we need to go. I'm assuming that Nikki can stay past the hour. Well, okay, yeah. So I don't know. Any questions, eSaúde team, about this approach?
Yeah, so I don't know if you others have questions, but I like the way Bomni have done where they're splitting things per form. Other people will want to split things per reports they are running and so on, but I prefer the perform one. Maybe we can share some other ideas from about the way they've done it. But yes, correct. But for us, what we were doing initially was just to come up with a quicker way of writing a report and the things that we need from a report. So it was like a report based. But from this end, we get more insights on how you can improve what you're doing.
So similarities to what we saw from PIH in terms of translating from MySQL to another MySQL database to flatten things, using some generic approaches in terms of flattening things from the data model to simplified tables. A little bit of some Bomni specific needs in terms of like the forms and stuff. But it looks, there's a lot of similarity to the basic approach of getting from the normalized to kind of denormalized views.
The notable thing is probably using Spring Batch instead of using Pentaho
Yeah. So the tools used to do the transformation are different. Yeah. And then the one question I don't know, did you say how often? So you define the model and went into that. How often is it run? Is it running continuously? Is it run like overnight or?
So currently we can run it overnight, or it can be on demand. Whenever someone wants it, they can run it actually.
So this
It's
is
based
not,
upon implementation's need. This is not a deployed end.
This is still being developed as we speak. It's not live yet. It's being quite actively developed.
Okay, so it's not. We don't have examples of like how it functions in different size implementations.
We are doing those tests actually. It's like it takes from something around to 15 minutes to 1 hour actually. Like we are experimenting on different sizes of data and based on different implementations. And we are also seeing how we can improve the performance.
So do you have specific reasons why you chose Spring Batch as opposed to what PIH and eSaúde maybe they're using Pentaho? Is there good things with the Spring Batch that Pentaho cannot do?
Sorry, yeah. Your voice.
The question is why Spring Batch instead of Pentaho?
We haven't explored Pentaho actually. We were using Spring Batch earlier also for doing exports in Burmese actually. And we saw the Spring Batch performance wise it's good and it's very what you call adapted and most of the people had used the Spring Batch. So like in our analysis, based on our analysis, that Spring Batch was widely used. It's a very effective way to do batch jobs actually, like reading parallelly, which will reduce the time, and there are a lot of advantages we can take of Spring Batch actually.
Maybe one answer is, I don't think the team didn't particularly find that the graphical interface of Pentaho was going to be especially helpful. And being able to being able to write code when necessary was more useful, especially to be able to like have a configuration driven approach where, or to do some of the interesting queries about what does a form look like in Bomni, or what are the concepts in a form.
I would just say, just having used Kettle and our approach, I mean, there are definitely things that are harder to do when you're using that framework. The reason we chose it over a more Java-based framework is just because we wanted to make it more accessible to a broader set of our team who are not necessarily Java developers. So we have extended teams, implementation teams in the field who are part of our MEQ team, or part of our EMR team, who work in sort of data analysis or business analysis, and they're able to go into Pentaho and learn the tool and write basically SQL and using some of the existing transforms in that tool, and write their own downstream pipelines and jobs and transforms for their own data. And so we found that it's a way to sort of accomplish more with the teams that we have. I also say that the way we're running Pentaho and Kettle, we've written like a lightweight Java Spring Boot application that actually includes the Pentaho libraries as Maven dependencies and then executes them. So you can actually use Pentaho Kettle in a Java-based environment. It's possible that these aren't mutually exclusive to each other.
All right, I gotta drop off and join a different call now. But I hope to look back at the notes and see more about Empath, what Empath is doing.
All right, thanks, guys. Should we move on and let Empath speak to what they've been doing? Nikki, do you want to do a screen share?
Hi. Hello?
Hello.
Oh, my network is a bit unstable. So I'll just paste something on the...
Hey, I have one more call. I need to drop off.
All right, thank you. Thank you very much.
Thank you. Thank you.
Hello? Hello?
Hello.
Oh, yeah, so I've pasted something on the notes.
Yeah.
Okay, so I'll just go over that quickly to just let you guys know what we are doing and what we're planning to do with regards to data warehousing. So what we currently have in production, we have a single OpenMRS database. We are doing central server, and that database has approximately 8,000 encounters and to 60 million orbs. So basically for us, we are relying on MySQL to do data warehousing. And basically we are denormalizing that data and ending up with flat tables, just like the other teams. So we have two flat tables. One is for flat orbs and the other one is for flat orders. This is basically, the reason for that is most of our analysis rely on those three tables: encounters, orbs, and orders. So after coming up with the flat tables, we further generate other specialized data sets. For example, we have an example is a monthly HIV data set that basically contains analysis for a particular month. So we do batch processing where we run MySQL scripts that generates the flat tables and also the analyzed data sets. They run every 5 minutes. We have some running hourly and some nightly. The reason as to why we have some running every 5 minutes and hourly is because we require some patient level analytics that our point of care application consumes. So we do incremental updates on our ETL store, and we find that efficient. So rebuilding of everything, flat tables plus our analyzed sets currently takes up to 30 hours if you decide to do it from scratch, and therefore it's very inefficient. So we've recently started using Elasticsearch for some of our analyzed data sets. And this was in order to leverage the Kibana visualization tools, because we don't want to start coding every visualization to do analysis. And therefore we made that decision to just sync some of our analyzed data sets into Elasticsearch and leverage Kibana for that. Yeah, so some of the challenges we are facing, the key one is scalability issues. And we can no longer add new data sets, new analyzed data sets into our pipelines. And that's because it just adds up to that 30 hours. And yeah, so we've reached at a point where we're running into those performance issues with our ETL processes. This is mainly because MySQL is inefficient. It does not utilize server resources well to speed up the ETL process, and it does not scale horizontally to utilize additional commodity servers. The other challenge that we are facing is dealing with hierarchical data, and that's mainly orbs group. Currently, we don't factor in orbs group into when doing our analysis, and we want to, yeah, so that's one of the challenges that we are currently facing with our ETL process. So right now, we are doing R&D at the moment, looking for better solutions, mainly to address the challenges that are highlighted above. So we are looking for a faster data store, we're looking for real-time or close to real-time analytic solutions, and we've been investigating whether we can do real-time analytics using stream processing solutions that are out there. So what we are looking for is solutions that can scale horizontally, they're distributed, have high throughput and low latency. And we've identified a few technologies that we've narrowed down. One is Debezium. Debezium is for change detection on MySQL databases. And that change detection is converted into a stream. We are using Spark to process that stream and also do some enrichment. And we're also looking into storing our analyzed sets and flattened data sets into NoSQL DB, such as Elasticsearch, Cassandra, and what have you. The main motivation being the ability to scale horizontally and high throughput. Yeah. Hello?
Yeah. Any questions?
So what we've just learned from Nick, whatever we are doing in a hurry mode, we might get to a point where things will crash and we'll need to redo it again. So this is very helpful. So we have to plan with the extensibility and flexibility in mind.
Yes, definitely. And when selecting these solutions, you want to consider solutions that can scale horizontally, meaning you can add additional nodes into your clusters and in order to achieve some scalability, to improve speeds and to increase the ability to handle new data sets. Definitely.
Excellent. That's helpful. Idris, are you finding good things here, or we're still in the lab?
Let me just add a few things to what Nikki said. I would highly recommend that you try and do incremental ETL rather than rebuilding. I'm not exactly sure why I mean, I guess we started off with trying to rebuild everything, but it's not that hard to do incremental updates and run them more frequently, you know. So I would push you to just try and figure out how to do that from the beginning, and it'll make your life much easier.
You mean, when you say that, you mean like being able to bring over data, transform data as they change or new data are added, rather than redoing the entire database every time.
Yeah, and you don't need I mean, yes, we're using a fancy solution right now, or we're trying out a fancy solution with Spark and Peter, thank you. Sorry, I have two children in the background, but right now we're not doing anything fancy. We have SQL scripts that run as cron jobs, and basically, can you color? Sorry. Basically, what we first do is we flatten the obs in the orders, as Nikki was describing. And that process is extremely fast, actually, with OpenMRS, in terms of getting out the obs that you need. And then,
if you're doing incremental, if you're doing incremental updates, you mean?
Yeah, and then all of our tables that we use for analytical purposes access just those flat obs and flat orders tables, plus the other kind of meta or just other data tables in OpenMRS, like person name or person attribute. But those things are fast to query because they're not that big. But the key is to get out of the obs table. And so from a performance perspective, we actually run this on our production database, and we run it such that first we hit the obs table. That updates because we have maybe anywhere from 10 to 100 encounters coming in every 5 minutes, let's say. It's normally not very much. It's a very small amount of data. We're talking megabytes at most. So flatten those, and then we run our other tables on top of that flattened obs table, and we do this kind of regular expression pattern matching approach, which works okay. And all our code is up there, so if eSaúde is interested, we're happy to kind of figure out how to help you out. But I think that's the purpose of this call. I apologize I joined late. But I would really stress that whatever solution you do, try and figure out how to do that. And the other useful tip that I would say for eSaúde, because I'm suspecting that if your reports are similar to ours, for the most part, you're doing monthly reports. What we've done is we've built a specialized data set, which basically does one row per patient per month. Okay, so, and we've only built it for the past 3 years. But if you look at, so that data set will have, for the month of January 2015, for every patient that ever had an encounter in 2015, there'll be one row per patient for that month with the most recent data for that patient in January. This makes it extremely simple to do time-based analyses on the monthly level. If you need more fine-grained levels, then build one per week. You end up with a lot more data, but we're still talking for the past 3 years of data. For the past 3 years of data, we're looking at only like 12 million rows or something like that. It's not that big. And I'm guessing you're not going to be doing too many reports on analyzing data that much older. No. Why don't you go play with your choo-choo? All right, I'm out. Sorry, guys. Too many people in this room that need attention.
Thank you.
I think unless there's any very specific questions, I know you're over time anyway, but if those are things that you're more interested in, let's find a follow-up call to do it. And one last thing that I'll add about Elastic, the reason why we pipe data into Elastic is because we don't have to worry about indexing. So if you're doing a lot of ad hoc reporting and new queries are coming up and you haven't indexed, you don't have to add new indexes every time you want to do a new query. And so it's extremely performant. And it comes with Kibana, which is a pretty decent visualizer. So I think that we had a architectural hurdle that I think initially, maybe you're already past this point as well, but you could be very cautious about adopting new technologies and just trying to do everything in one approach. And we've kind of just accepted that for our needs, we're going to need multiple technologies to solve the problems we're looking to solve. And so we've set up an architecture which allows us to basically do that. And we're embracing using multiple databases and multiple technologies in order to achieve our ends. And from the little that I've been reading, it seems like a lot of modern web application kind of adopt the same philosophy, that there's not one database that will do everything that you need it to. And there's, anyway, I'll stop there. I'm going to go back to mute, but.
Yeah. And the other piece that I would layer on this is that there's a question of flattening to what is a fairly generic but flattened version of OpenMRS data, which it sounds like PIH. They're basic, like the initial phase of PIH is trying to do. Bomni does something similar, but it's a little bit different. And I think in terms of what Ampath has done, at least in their first, using MySQL and flattening, they're all, relatively similar in terms of having a table that has one row per encounter, or having tables that are a couple of the core tables in terms of forms or encounters are probably fairly similar, but it's an OpenMRS data model. Another thing to consider is, is there value in coercing data to a kind of a standard data model, and utilizing the tools on top of them? My guess is that's probably not going to be a near-term solution that eSaúde is going to want to consider. But just so you know, one of the potential or things that we've played with in terms of how to do reporting at scale with OpenMRS is using the Common Data Model, or OMOP, which a growing number of sites are using, where there's kind of a standardized way to represent clinical data, and then there's hundreds of companies building tools to do analytics and stuff off of that data model. So another option is to say, well, if we coerce the data into that data model, we could get some near-term wins of being able to use other people's tools. My gut instinct is, as Ampath is pushing, is that the really scalable approach is going to the kind of NoSQL, leveraging the horizontal scalability of the NoSQL approach, because inevitably when you do data warehousing, traditional data warehousing, you're trying to denormalize and design tables in a way that you can run your reports and answer your questions. And you create this pipeline that says, okay, the data from this model will get flattened into these tables so that I can answer my questions I need. When you have a fixed data model that you're coming from and a fixed set of questions, the typical data mart works well. The truth is that our data model in OpenMRS is really not the data model in MySQL, but it's the concepts, and it's the medical, the model, the way we view data clinically, and that is constantly changing. And if you haven't already experienced, I think folks quickly experience when you're trying to manage both M&E as well as reporting needs, what questions get asked is kind of a constantly moving. I know in a research setting like Ampath, that's very much true, but I'm sure a lot of implementations end up in that situation where there's always new questions coming of the data. So you end up in a scenario where your data model is in constant flux and the questions you need to answer are constant flux, where the traditional data mart starts to fail you. And so that's another reason that I think there's some longevity or some future proofing and going kind of the NoSQL approach, where you don't upfront commit to, oh, this is the model everything needs to fit into, and rather take advantage of the kind of newer tools that allow you to kind of your schema to change over time. And as they found with Elasticsearch, the indexing is kind of more flexible. So, but it's also obviously it involves the complexity of having to manage additional technologies and get up to speed in terms of their possibilities. And eventually, I think where the happy place is probably some combination of these things, where there's like a quick and dirty for the small implementation, translation into a flattened MySQL, but then we build maybe leveraging Spring Cloud or Spring Batch tooling that moves things, translates things as needed in a configurable way into NoSQL databases for scalable and horizontally scalable use, for the larger implementations and larger needs. But
if I can just add, I just think that, like, as you said, Burke, for the most part, questions are like very specific to not just an organization's needs, but how you've decided to collect the data. And that makes me less optimistic that there's any sort of kind of generic solutions that work across different organizations. I mean, even within an organization, we have to create different data sets to answer different questions. So I don't know how you could generalize that, but certainly the level that we would welcome collaboration on is, we have this flat obs table that we just basically make a bunch of key value pairs between the question concept and then whatever the answer is to that question. And that representation is going to be useful probably across any OpenMRS implementation, because basically that's just putting pieces back together. Any sort of kind of semantically enriched data set that derives from that will likely be very organization specific. Perhaps there's processes that we can discuss for how to transform from, the generic encounter rebuild to that, but certainly the data itself, I think, will be very organization specific.
So have we made your life more difficult, eSaúde?
I think the life is more easier. It is not that difficult now. What you are doing, you are in the dark somehow, but now we've got any more insights on how we can improve on what we're doing. I think we'll do better, and we'll continue consulting where we get stuck and where we can get help from the community.
Yeah, I mean, the last bit of advice I would say is to the extent you can be transparent in terms of as you work through the process, because everybody, as you can see, is kind of going through the same pains, and whether it's with Bomni or it's with Ampath or it's with PIH or some combination, if we can find places where maybe not the entire stack, but there's components where eSaúde and another group are putting, working together on it. There's potential win in the collaboration. You don't have to set yourself up where you have to collaborate or else. But I think looking for, okay, here's what we need to accomplish. We're 80% of the way there if we say adopt kind of the approach that this other organization did. Maybe the effort of saying, well, maybe instead of putting 100% effort into rebuilding what they've done to meet our own need, maybe we could direct that effort and some community effort to taking their tool or their approach and making it generic enough that it truly is useful by multiple organizations. And if that works out, that's great. But I think at the end of the day, you need to be focused on what eSaúde needs and set yourself up for success no matter what. I mean, when I think of how we pulled off OpenMRS in the beginning, it's not like Regenstrief or PIH said, okay, well, we'll commit to collaborating, and if the collaboration succeeds, then we're good, and if the collaboration fails, then we fail. The main reason we collaborated was that we had similar needs, and we figured we'll do half the work and they'll do half the work, and collaboration takes a little more energy than that, but in the long run it ends up paying off immensely. So appreciate your guys bringing this to the forefront for the community, and I have a recording of this call, and I'll get it. I'll post it out on YouTube eventually, so that not in case anybody wants to come back and kind of look at what was discussed, and we'd be very interested in just as you kind of work through the issues and make some decisions to help you be successful. So keep the community informed.
Thank you very much.
All right, thank you.
We've been so helpful to us. We thank you. And will you attach the audio on the talk thread?
Yeah, as soon as I get the video uploaded to YouTube, I'll share it on the talk thread.
Thank you very much.
All right.
Dries,
Thanks, folks, for joining.
Okay, thank you.
Thank you very much, everyone.
Cheers.
See you in cyberspace.
All right. Bye.
Thank you very much.